Good afternoon, guys. Today I'm going to talk about um, few problems. I think this is very important to solve problems. So there are four neural nets. Let's say A. The neural net would look something like this: X, Y, something its weight. It goes into weights and it has something. And there is one neuron, which there is a. This is A. Let's say there is a B neuron which has three neurons, three processing units, X, Y, goes here, goes here, goes here, goes here. Okay. Now it comes out of it one neuron. These are all having weights. These are all weights. There's one neuron that comes out. There's the C, okay, which has one processing unit, X and Y, and outcome. And D is the one which has 1, 2, 3, 4, 5. Okay, X, X1, X2, X and Y, something like this, right? So these are the four neurons that options for you to choose. Now let's say I have a figure which shows the outcome, okay, wherein it has something like this. Okay, these are all. This is the shaded area that it has to identify. Okay, so if this shaded area is what's supposed to be identified, tell me which neuron, which of these four neurons. It could be multiple also, not just one neuron. It could be any of these four neurons could be something which can identify this part of the portion as a good neuron. So which one would you choose? Which of these would you choose to give you an output of this particular option? This is a quiz kind of a thing. So you can pause the video, switch it, pause the video, see what could be this is the problem number 1. Okay, if this is the graph given to you, what would be your options out of this A, B, C, and D? Which one would you choose? Okay, pause. I'm going to pause. You should pause the video and then solve it and again rerun it. Okay. Okay, welcome back. So if that is the case, see there are two lines that have to intersect. That means there has to be some kind of neuron which actually goes and identify that, and this neuron that identifies and mix them. Out of this, the mixer is there in A, B, and D, but not here. So the answer could be A, B, and D. Okay, this could be the answer. This is the answer. This could be. This is the answer. Okay, something like this. Okay, so this is where you should be able to. This is how you should be able to identify. That means there are two equations going. When there are two equations going and it has to mix, then there has to be a mixer. These are the weights. Something which goes in there and does something. This is not the one which actually directly goes into the weights and coming out. So that won't be a good option for it. Now, second one. Okay. Now let's say I have second one is that this is the thing and this is the portion. Okay, this is the portion it has to identify. Does any of this identify? Maybe the fifth option is E option is none. Okay, I should have written the answer is there are none of the choices. Okay, now if you look at it before you do anything, pause always. Whenever I give you a problem like this, pause, work it out which one makes sense, and then run it. Okay, the answer is none. Okay, now let's take another equation. Okay, let's take another net figure which will identify which of the neurons will get identified as will identify that particular figure. Okay, now let's take this. This is the third quiz. After I drew, you should stop and then do it. Okay. Okay. It has to identify this portion. Any of the neuron that makes sense that will identify such a neuron. Okay, welcome back. I always say pause it and then answer. Okay. Now this also there is none. Okay, why? There is no two. There has to be a particular neuron like this for this, another neuron like this for this, and then mix it. That means there has to be here it doesn't show. There has to be another one which goes like this and then come here and then do it. That is not being done in one of these four choices. So it won't be. None of the neuron matches to identify this particular part of the function. Okay. Now let's take a fourth one. Now I think you are able to understand when you are able to see such things, you are able to identify such figures and then identify which neuron actually makes sense. Okay, this is the fourth one which I am giving. Fourth one, again I will always request you to pause and then work it out. Okay. Now this portion and this portion. Do you think any of the neuron which will help you identify such a thing? Okay. That would be D. You might ask why it is a D. Now let's look at it. This is X and this is X1, right? So there is this portion of where one of them will be able to identify this particular portion, and the same equation can be used for the rest of the thing where it can identify this part of the portion. Okay, where it says here there is this and here there is this, right? There are two things. One is a conjunction of this and one is a conjunction of this, but not in the previous one where it was like a triangle. Here it is. Why? Because here I can take, let's say this is going at 3. I can say x is equal to 3. And here y it is going, let's say this is going at 4. So y is equal to 4. One of them would be less than this, would give me one option. Greater than this would be give me another option. For it to have a intersection of these two equations. So D will be the one which will actually identify such a neuron. A neuron of such of this one will identify that. Okay. Now let's go for this one. This is the fifth one. Okay. Fifth one will identify something, a portion of this part. Okay. Okay. This part, the red portion, is the one which it is to identify. Which neuron will help out? Pause the video and then answer and let me know. Okay. Okay, welcome back. The neurons which will help you identify these are all of them: A, B, C, and D. Because there is only one equation. In that one equation, you can make one of them as this, as if this is y is equal to 3, you can make this 0, and it will come out. Same thing here, same thing here, same thing here. So you will be able to get the output based on that. Okay. Now let's take one more and then we'll stop this part of it. Okay. Now we will take this one where there are two portions. Okay. The two portions are something like this. This one and this one. Okay. It will be very difficult to understand if it is not marked in red and black, blue and red. So which one will make sense to identify that? Okay. So here there are two portions, but there are still X and Y only, right? X and Y, but two portions. Which of this neuron will help you out? The B one. Why? Because one of the neuron, one of these two will identify this part, one of these two will identify this portion part. So the B neuron will be helpful. Okay, so this is how you solve the figures, and the neurons that might be equivalent are the one which will identify both of them. Okay, now let me pause a little bit and I'll give you another. Okay, welcome back. I've written a graph over here where there are two lines. Okay, I know that's all kind of jumbled up, but one of this line, which I'll name it as B, this name it as equation A. Okay, line A and B. Okay, so we need to identify that which is positive. The ones which are in between A and B are the positive values. The ones which are outside of this, outside of this are negative. That means we don't need to worry about, but we need to find out the intersection of these two lines which falls under this portion. And first of all, let's identify this portion, then I'll draw another neuron wherein we need to identify, based on these equations, we need to identify the neuron part. Okay, the values that satisfies this particular figure, we need to identify a neuron. So that's one of the questions which will help you to understand how to identify a neuron, how to put the weights, how to identify the threshold of a neuron such that the neuron, the output of it comes out properly as per the lines or as per the figures that we have drawn. So let's find out, first of all, is related to the first thing is related to this particular thing is what is A and what is the equation of A and what is the equation of B. Okay, equation of A is equal to, see, it passes through 3 and there is one line which one of them is this one, which is 5 and 4. So there is one coordinate which is 5 and 4 and one other coordinate is 3 and 0, right? So based on this, this would be 4 minus 0 by 5 minus 3, which is 4 by 2, which is 2. That means, so y is equal to mx plus c, right, which is 2x plus c. So where does c actually intersect? It intersects at if I make this this coordinate 3 and 0, that means 3 is equal to 2 into 0 plus c. X is 0, no, x is equal to 3, so x is equal to 3, y is equal to 0. That means c is equal to minus 6. So that means this equation y is equal to 2x minus 6. So this is the first equation A. So that's the first thing we will find out, that the first thing about this is equation A is equal to y is equal to 2x minus 6. Now let's talk about B. B has one of the equation is at 0 and 2 and other is 2 and 4. 0 and 2, 2 and 4, right? So this would give me 2 minus 4, 0 minus 2, minus 2 by minus 2, which is 1. That means, and C is anyway is equal to 2. So y is equal to x plus 2. So this is equation D, right? So once we get this equations correctly, then we have to identify where does it fall into. Now the one which actually has to fall, how this equations needs to be represented in the form of ax plus b by y is equal to x plus 2, right? The equation should be in the form of ax plus by plus threshold is greater than or equal to 0. So this has to be satisfied. The equation has to satisfy this particular thing has to be satisfied. So to satisfy this part where a this side and b is on the, it has to be greater than this, a b has to be greater than this, a has to be greater than, but finally it has to represent in this form only. Now let's take a, which is of the form of y is equal to, that means a should be a, y should be in the form of a y less than or equal to 2x minus 6, right? Y is y less than or equal to 2x minus 6, but it has to represent, I have to flip it, which is 2x minus 6 is greater than or equal to y, right? It has to be done. Now I have to bring this y this side, which is 2x minus y minus 6 greater than or equal to 0. This is the first thing. The b is y should be greater than or equal to b should be y. Coming back. So this is the neuron, okay, wherein the output is shown, which will show an output of this intersection of these two equations. Now, how do we solve this? So there is this weight one which has to be, which x1, if the x gets it, and there is a y2 portion which actually it goes through like this, it goes like this, okay, for that. So there is this has to happen, this has to go through this. This is the sigmoid function. Now what is the equation that positive, but in the figure we need to get the positive output, okay? Output is the positive thing. This is one neuron, this is second neuron. Now what are the weights that needs to be filled up? See, there is this weight, we don't know. There is this weight, we don't know. We don't know the threshold. We don't know the threshold that is here. We don't know the threshold over here. So we need to fill all these things so that the neuron comes out of it. So here, look at this. This is from this neuron, A is going, right? The threshold A is equal to 6 here. A is going here. From here, the B is going. Okay. So that means now we know exactly what is the values that needs to go through these things. Okay. Now let's solve the A part of it. It says 2x minus y minus 6. See, this 6 is already put. By default, there is this minus 1 which is already there, which if it multiplies, that means this 6 is set. Now what would be the W1? This W1 is 2. Why? 2x, right? This is set to 1. Why? Because this is minus y. Minus 1 it is set. Okay. Minus 1. Actually it is minus 1. Okay. Not 1. Minus 1. Why? Because this is minus 1 that is set over here. Now if this equation is set, now we'll worry about this later, but let's come over here, which needs to be identified. Now that W explaining here so that you understand. So y is equal to, we did that y is equal to mx plus c, right? Y is equal, now we were supposed to understand y is greater than x plus 2 or y is less than x plus 2. Now if I take 0, x is equal to 0, y is equal to 2. But if I take x is equal to 1, y will be 3. But it will not be in this portion. That means y has to be less than this one. This equation, it has to be less than this. So that's the reason y should be less than or equal to x plus 2. That means it has to be less than. If this is the equation that I need to consider, that means I need to consider this as the correct one. then x plus 2 is greater than y, x minus 1 plus 2, which is in the form of ax plus by plus the threshold is greater than or equal to 0. So that means I have to consider this as the correct equation, which is x minus y plus 2 greater than or equal to 0. Now, taking this into consideration, okay, I will erase this part. Please look into this particular equation, why it has to be this one. Okay. Now, if this is the case, you need to be very careful of to which particular portion has to be considered for the equation. So that means I have 1 over here and minus 1 over here and plus 2 here. That means that W3 is equal to 1, which is x, which is getting multiplied through x, right? Through x, okay. This W3 into 1 is x, but this has to be minus 1. Okay. Now TB, the threshold of TB is minus 1 is already given, but here it is plus 2. That means this has to be minus 2. Now these two intersection has to be considered to get me the output out of it. Okay. Here the output, to recap, this is a little tricky, but anyway we'll solve it. The one thing that we need to understand that this A and B. So again, looking at the portion of the graph, it was like this, right? That means anything that falls over here is good, and this is A and this is B. We consider that and A and B as the lines, and anything that falls over here is good to go. And that means the intersection of all the B over here, and if A is considered all the not A, that means anything that is not this but this portion of it. Now if you consider the truth table, this is a mixer of truth table of AND portion. That means it is not an AND, it is an AND, right? This is the intersection which we need to consider. So we need to consider a different kind of a this thing where it falls over here. We know that, you remember we did this AND thing, right? That which falls over here, that which falls over here, and that the one thing which we need to consider the intersection. That means not A and B. So if the truth table to this is A, B, A 0 0 0 1 1 0 1 1 and not A, right? Not A is what? 1 1 0 0. Now if you consider an AND of not A and B, right? This is the portion that we need to consider. So that means we forget this part. This is the two. These two are the things we need to consider. That means we will get 0 1 0 0. That means when it is 1 and when it is not A, that means not A in the sense if this is the thing, we have one portion which gives us this part, right? This part as the original one, not A. That means if it is 0, we need to consider as 1, and that will be 1 and 0. 1 and 0 will be negative, which is negative here, and 1 and 1, 1 of 1 and 1 of A, that means this and this will be the one which is a positive one. The other one will fall on the negative side of it. That means anything that is this portion is the one which will come out of this particular sigmoid function. That means anything out of this will be coming over here as the output of this. Then in that case, what is the equation to this one is, I have which will cross over here at minus half, okay, at plus half, okay, the C is plus half, and this will cut off minus 0.5. right? Minus 0.5. So the equation will be something like, the equation with this would be something like um, minus a plus b greater than or equal to half. Okay, that means minus 2a plus 2b minus 1 greater than or equal to 0. So that means this is the weight, this is the weight, and this is the threshold. Okay, minus 1 is already there, that would be 1. Minus 2, this is here, plus 2 is already set here, plus that which comes from this is plus set, so this would be minus 2. So minus 2 will be W5, minus the plus 2 will be W6, and this will be in this fashion, or it could be minus 1 also, but this is plus 2, this is already set, so this is the solution that needs to be appropriately set, or this could be lesser than that, or this could be half, 2 and minus 1. So there are two solutions to this. One is the W5 can be is minus 2 and W6 is 2 and TC is equal to TC is equal to 1. The other one could be W5 is equal to minus 1, B is set to 2, 1K, and TC is equal to half. Okay, so this is the second solution to this same problem. So there are two solutions to this, which will be appropriately done. So again, take a look at the whole way that I have done it. Okay, try to understand this particular portion of how to solve this. Okay, you got an output, but that doesn't mean that you need to fix it here. This is an AND portion of it. Now, how do you do the AND? Again, we need to do another graph of it, considering A and B as an equation, and see which one actually makes sense to come out with a proper solution. Then you will be able to get the weights of this. So this is a little tougher problem which I saw.